Okay? Now this was all a nice blue surface when we started, and we're continuing to heat. So as we add more heat, we're going to see more white appear, which means the hydrated copper sulfate, or the copper sulfate that has the water attached to it, is slowly, as the heat is being applied, losing the water. And fortunately for this demonstration, and why it's such a good demonstration, is you can see the difference in the color. No, it doesn't, there's not enough of it coming off. So, now you see it almost looks like something's growing on the surface, doesn't it? And the brown that you're seeing is the copper 2, or copper in the 2+ state, changing to copper in the 1+ state. An electron makes a difference. Really makes a difference. Oh, there's more little brown spots around. See them? There it is. It's just kind of fun to watch. And once in a while you see a little bit of a wavy motion in the picture, and the reason for that is the water being driven off. And you get water in the air, and it's like, oh, look at this guy now. See? The one on the far left I was just pointing to. And, oh, you look at the little brown spots around the crystals. See them?
Yes. Oh, yes.
Okay. They're not only on the tops of those crystals, but also have kind of been driven off by the water boiling and exploding on the surface. Yeah, literally exploding. Exploding as water will do as it turns into steam. And it just turns whiter and whiter and whiter. Now, I'm thinking that if I don't drive this too far, I can turn this back to pretty much as it was. And we'll see about that, because I'm going to turn the flame off so that it can cool a little bit, and then we'll have a chance to look at it after it's cooled down later in the period. Okay, so let's go ahead and start the recording again. And now this has been sitting for what, 20 minutes? 10, 15 minutes? Whatever. So it's been, and you see it has gotten much whiter. And that's just because there was residual heat in the dish itself. Okay, so let's see what happens when we put a little water on it. What's your prediction? What's your expectation?
Blue.
Blue. Okay, well, let's see. Just a little. Okay. Are we getting blue where we had the water? It's blue because with the water, the hydrate, which in this case is magnesium sulfate, is formed, and that is a blue, and the magnesium sulfate, or the copper sulfate without the water is a white. And so we're seeing it hydrating back now. It's kind of soaking in. As it soaks in, the crystal takes water in at all levels, not just on the surface. And so this dried out pretty well. And we can still see the specks down in this area, and those specks are telling us that we have some copper 1, where these guys are copper 2. And as the water soaks in, it just gets bluer and bluer, which is really kind of fun to watch. Okay. See how it kind of bubbles a little bit, almost like a bubble coming out, and then it turns a bluer color. Let's see if we can get a little water on the end of this guy, a little more. And that end now will turn a little bit bluer. And Could you see how in this area it kind of spread out a little bit? If you're watching this at home, you can back it up a little bit. And yeah, there, you saw some more spreading? Okay, as it's soaking in, it's turning it more and more blue. And that's just the beauty of this of hydrates, to change colors when they have water or no water. Okay, anhydrous, we call it no water. Hydrated is with the water. Okay. Now you can see that the little rocks of copper sulfate have gotten more blue, and you're also able to see around the edges here, follow the little hand around, that greenish color from copper being changed to from copper 2 to a copper 1. And that changed because of the heat that I applied. And every time that you heat this and then put the water back in, you get more of the green species of the copper ion, which is a 1+. And the blue species is a a 2+. And that's how the hydrate thing works. Hope you enjoyed.